Hello and welcome to all of you. Today we are going to discuss JEE Mains 2017, and today I am here to discuss the paper of physics code A. So let's begin with the question number 1. Question number 1 says a man grows into a giant such that his linear dimension increases by a factor of 9. Assuming that his density remains same, the stress in the leg will change by a factor of. So what will be the meaning of this question? The question says that a man, suppose if I consider this is the situation or position of a man, this. So if length of the man will increase, then you can conclude that area of cross section of the man will decrease, right? So, but we can say that in this situation A into L is constant if I compare this situation like a stretching wire. Okay, so we can conclude L is inversely proportional to A, right? But according to the concept of stress, we can write stress is equal to force upon area. So I am using weight because question says density remain same. So weight will be constant. So stress is inversely proportional to A, and area of the cross section is inversely proportional to length. So we can conclude, because question says the linear dimension increase by factor 9. So my option is 1. Okay, so now we will move question number 2. In this type of question, a body is thrown vertically upwards. Which one of the following graphs correctly represent the velocity versus time? And I am saying that the total number of graph is 4. So if I visualize the situation, this is the position of the body, and this body is going to up. So acceleration of gravity acting downward. On the other hand, we can say that the direction of acceleration due to gravity will act in downward. So we can write equation V is equal to U minus of gt. If I compare this equation by equation straight line like mx plus c, right? So if I change the scenario of the equation, so we can write minus of gt plus c. If I consider this is my equation number 1 and this is my equation number 2. So if I compare these two, we'll get slope of the graph is equal to minus of g, and the value of c is only, the value of c is u, right? And if I go for graph number 1, so here you could see my observation will tell you the value of initial velocity will be positive, but graph number 1 will show, is showing that graph number 1 आपको indicate कर रहा है कि initial velocity is equal to 0, but this is not possible in the situation. If I go, option number 1 is not correct. If I go for option number 2, so here you are seeing that graph number 2 will indicate, you know that time can never flow back. So graph number 2 is not correct. But if I go for the equation number 1 and 2, then you are seeing that easily you can say that graph number 3 will be correct. But if anybody asks to you what is the reason for graph number 4, graph number 4 will show speed time graph, because velocity may be negative but speed can never be negative. But this graph represent द सिचुएशन ऑफ इक्वेशन नंबर 2, हमारे बॉल की कंडीशन को, हमारे मोशन की कंडीशन को जो ग्राफ नंबर 4 शो कर रहा है वो इन टर्म्स ऑफ स्पीड शो कर रहा है. So we are not going to take option number 4. So my final option is third. Now we are going to take question number 3. This is very important or good question, and basically this question is from work, energy and power. So in this type of question we will move from work energy theorem, and work energy theorem shows that the work done is equal to change in kinetic energy. Change in kinetic energy means, first if I write half m final speed and initial speed. So we need, in this situation, there are two type of speed. One of them is initial speed, another is final speed. But what will be the clue? But question says force is F is equal to minus kV square. But I want to calculate initial speed and final speed. So in this stage, what you can do? So look at, if I change the force in terms of mass and dV over dt, so that will equal to minus kV square. So dV on V square, that is equal to minus k times of dt divided by mass. Because we need only a expression, an equation related to velocity and time. So if I go for integration like that, and now we are going to take the limits of the integration. So here you could see initial speed is 10, means at time t equals 0 my speed is 10, and after 10 if I consider my speed is v. So my first point of interest, calculation of v. So if I go for the integration, so what we will get? So if I go for this, so now you will get 1 by 10 minus 1 upon v, that is equal to minus km into t. My second requirement is v. But now question की तरफ जाते हैं. Question says the energy is 1 upon 8 mv naught square. You know the formula of kinetic energy is half mv square, but here you could see 1 upon 8 mv naught square. So can I say my speed is, on the basis of that, v is equal to 5 meter per second, because kinetic energy is going to half. So we can write here. So now if I go for the calculation of v, so 1 by 10 minus 1 upon 5 and k, but according to the problem mass is given 10 to the power minus 2 and time is 10. So on solving you will get the value of k, that is 10 to the power minus 4 kg per meter. So we can say that my option is third. Third option will be correct. Okay, so now we are going to move from question number 4. This is another question from work, energy, power. So now here you could see force is given, F is equal to 60. So once again we are going to solve this question by using work energy theorem, that is half m final speed and initial speed. So we need only two things, one of them initial speed and one of them final speed. So what you can do? So first I am going to write the given equation. F is equal to 6 times of t. You can write m dv over dt, that is 6 times of t. So dv is equal to 6 t dt. I am not going to write the value of mass because mass is 1 kg. So there is no need of the value of mass. If I go for integration at time t equal to 0, and what will be the value of speed. So after integration you will write v is equal to 6t square by 2, right? 6t square by 2, so that is equal to 3t square. Am I right? Now this is the expression of velocity or speed. So if I want to calculate my initial speed, then if I take time t equal to 0, that will give you initial speed. If I put according to the problem at time t equal 1 second, then you will get v is equal to 3 meter per second. So now question will becomes very easy. So if I go once again from work energy theorem, mass is 1 and final speed is 3, initial speed is 0. So you will get 1 by 2 into 9, that will give you 4.5 joule. So my option is 1. Now we are going to move question number 5. Basically this question is taken from system of particles and rotational motion. So now we are going to solve the question. Question says the moment of inertia of the cylinder, like that. If I consider this is a cylinder, length of cylinder is L and radius is R, right? But question says the moment of inertia about its perpendicular bisector, means like this. But we know that according to the condition of the given question, we can write the value of I. You all know I is equal to mr square by 4 plus 1 upon 12 mass of the cylinder and L square, right? But I want to calculate, or question demands, or question says find the ratio L by R such that the moment of inertia is minimum. This is the key point of the question. So what we will do in this type of situation, if I think, or if I go volume of the cylinder is pi r square L, right? So if I calculate the value of r square, that will give you v upon pi L, right? What will happen if I put the value of r? So expression will becomes m by 4 r square is v upon pi L plus 1 by 12 ml square. Because question says moment of inertia is minimum, so ti with respect to the length, but question says moment of inertia is minimum. So if I use the condition of maxima and minima, we can take di over dl is equal to 0. Am I right? But if I go for the differentiation of the given expression, so what will comes out? Minus mv upon 4 pi L square. You know this is the basic of the differentiation, plus 2 times of ml divided by 12, right? So now mv upon 4 pi L square, that is equal to 2 times of mass m and 12. By this, on solving, we will get the value of L cube, that will give you 3v by 2 pi. Once again, we can use the formula of volume of the cylinder. V is equal to pi r square L. So if I want to calculate the value of L, L is equal to V upon pi r square, right? Can I write L square into L? That is equal to 3 times of V upon 2 pi. So if I put the value of L from this relation here, so L square into V upon pi r square, that is 3V upon 2 pi. So V is cancel out. On solving, you will get L by R is equal to root of 3 by 2. So now we will move the question number 6.